I was just telling him that the papers that he sent me, that's how I got the inspiration for HP100, and the teardown. I did go through the teardown because one of the that's a really good teardown of the entire circuit. I have been MIA because I have been like I have friends over and then I have my MIA, but now I've taken 5 days off. So my intention is to work on this whenever I have time from my 4-year-old. So I want to put it. So I was telling Jay that I just want to put it together and then send it to him maybe by today or tomorrow, so that I know what it is like to put it together. Using how do you pronounce it? KiCad?
I pronounce it KiCad. Some people call it KiCad, but I think it's KiCad.
Yeah, and Seed. Seed is ready because Seed, I have been speaking to somebody and he's ready to do the parts for us and everything, and we can just copy him and send him the Gerbers and everything, and he's like he can do it. So once you test it out, I think they are ready to do it for us. So that's
okay, good. So the boards are DHL has a tracking number. And as typical with Chinese DHL, like you never really get any information until it like hits US Customs. Then you see all the history that happened before that. But so it could be here tomorrow. It could be here in a week.
Right.
But so when I get them, I'll put them together.
Oh, okay, cool. So. Then I can just talk to them, and then we can get it. We can get it together for the 433, I think, and then the 10. I will. So I have read through the teardown, and I have the other paper is what new, but there are a lot of. So I'll put it together and I'll send it to you. And yes, I can use MATLAB. MATLAB recently came out with an RFPCB toolbox. I am a writer for that toolbox. I write for Antenna Toolbox and RFPCB toolbox. I am a writer, so I did speak with them, and they are fine because this is not for profit, so they really don't mind me using. But it's still new, right? So.
Okay.
Still, but its first release is out and it's quite promising. So if people want to test it, we can just download the Gerber files and test it using that. I mean, like simulate it basically. That's the plan.
That's the plan. Okay.
But I will look into the software that you also send me, because as I told you, version 1 of RFPCB Toolbox is out now. So
okay.
I don't know how much,
yeah.
That's how much I can tell you guys.
Yeah.
No,
it's a project that it's constrained enough and relatively straightforward. So this should be a really good experience. And if we find out some interesting things about the toolbox, that'd be great.
Yeah, that's why they're also interested.
Good.
Yeah.
Yeah, very good.
Other than that, I don't think I have anything else. I am recently understanding that I really like the hardware side of it, that I really want to learn more.
Yeah.
It's something that is actually my interest has peaked since I've started. I mean, it was already peaked, but since I started talking to Jay, I know that I can, keep bouncing ideas back and forth, and he's so like, I mean, he's got so much of experience. Yeah.
Yeah, definitely.
Other than that, I don't have anything. I will keep quiet now.
Yeah, I have the HB100 here, the same one in the lab, and I've seen. So I've kept up with some of the dashboard work from AmbaSat, which is not bad, and some of the community work for dashboards is arguably better. So I think we've got decent visualizations and presentations for this. Yeah, so I guess what the biggest thing for me is to figure out, do we need any additional resources, or is there anything in anybody's way? Any actions that I need to do?
I think I'm good, because I will do that and I'll send it. I'm sure that it wouldn't be perfect, but I'm sure that he and me together will be able to figure out what is not working in that. But obviously, once that is done, maybe you said you have a printing board, like
Yeah,
you got.
I do. We have a Volterra here, which allows you to print circuits. So if we need to do something that we can't get made, then we can go ahead and do that. It's best for really very short loop, very tight loop prototyping. That's kind of what it's intended for, down to 0.2 millimeter resolution, which will get you down to 5 gigahertz pretty reliably. I don't know about 10, but for just figuring out if it is in the ballpark, I think that will work. And they do have a different front end, or the hot end for the Volterra, that might actually boost the resolution up a bit, but I haven't gone and actually tested it. So, but honestly, well, okay. So given the supply chain challenges, even PCB material is now short. So if we did need to fall back to actually printing some circuits here, then we can do that in San Diego. And for microwave, actually, CNC can do it as well. And we have 2 CNCs that we can use. So worst case, we can drill or grind or machine out some circuits if we have to. So I think we're in decent shape for doing prototyping if the regular supply chains fall through. I think we've seen that some of those parts are just not available quite yet. I expect that will change in the future, and it might change very quickly. All of a sudden, we might see a bunch more capacity or parts. So low pass filter everything is probably the best approach. I do have a question for both of you, and for anybody else listening. So I think we're looking at some really quality upgrades to this particular project and circuit, and that's what we set out to do, and that's good. There's been an awful lot of questions about whether or not we could expand this to be an ordinary FM satellite, like a FM repeater in space. So I haven't said no to that, but maybe we should probably look to see if we could use this as an anchor for a CubeSat, for a low LEO CubeSat. So just that may be on the horizon. What
so
we're also
you use it as a beacon in the CubeSat, like an FM beacon?
Yeah, because so we've removed already the major objection to putting this in space, which is that it's in the 915 and I believe 868 megahertz band, and that's just not. I don't think we're going to get a license from the US for that. That's my opinion, and I know that there's people that disagree with that, but in general, the FCC has made it very clear that ISM bands are not what they want to see in space. And I personally, I agree with that. So moving to something that does have a satellite allocation is obviously an improvement, and we're doing that. The next step is looking at the size of this particular payload, because it's very tiny, and it's really arguable whether or not the FCC would say, yeah, sure, you can put confetti in space, we don't mind. It might just be considered not a no launch sort of deal. Now we could launch it, and it actually an AmbaSat, a version of AmbaSat is scheduled to be launched from India. So we could find another place on the planet to launch it, but I'm thinking we could start out with this, and if we put it inside of something larger, that it was running the show or part of the show. So whatever we do, I think it's a very, very not the primary, but as a forward-thinking goal, kind of look at maybe, is there anything that we're doing that would prevent it from being included or integrated into a 1U? And so far, I don't see anything, but I don't have the same eyeballs that you all have, and the same fingers on control. what we're looking at doing is using this particular project to go ahead and pilot through some changes to the regulatory application process for Part 5, and also for amateur and for IARU. So that's what we're looking at doing, is to go ahead and actually try to get a license to launch it, and to make some improvements in the regulatory process for experimental launches. But again, that's a modular thing, and creating a circuit that works, that's a AmbaSat that's legal, is a total success. So the things I'm bringing up should not be interpreted as mission creep necessarily, just that this is in a larger ecosystem, and it can play a role. And if we can make it turn into amateur payload that could get launched, that would not be necessarily so tiny, that might be a path forward to getting this in LEO. Now, the shorter term, I think that there's some talk about some negotiations and some discussions about some sounding rocket tests, and that's super exciting. And that would be extremely useful. And I'm going to raise this. Let's see, today's Wednesday. I'm going to raise this on Friday. There's another call with a university, so I'm going to ask if their sounding rocket might also be a host. So if we can get multiple launches and start testing things out, then that would make the eventual space licensing, I believe, easier and more plausible. But yeah, the size now, so we've removed the frequency objection. The band was definitely illegal. So now looking at the size, that's what I keep hearing as a potential objection. These are informal objections, but I mean, you just have to kind of look around and see what the FCC has done in the past. So that's what
there was a KickSat mission, right? That had the similar size.
Yes.
And that was a NASA,
at
least encouraged mission.
Right. Yes.
And they had just one
that,
like the tiny one, and just one of them that they. Oh, okay.
I think so. Yeah. And then there was another one, Flitter. Is it Flitter or Flicker? It was a launch that got denied an application because of size, and then they launched. Yeah, they launched.
Oh, right.
They launched anyway.
Yeah.
Which and then came back to the FCC and said, okay, we'll try again, and applied again. I lost track after that. But so size. This is on the edge of.
Yeah.
What
is the what's their? Yeah, what is the edge?
Unclear, because they won't tell you in advance, but the general rule of thumb is that they would really like it to be 1U or larger, I believe.
Okay.
So.
All right.
But we'll see. There's a lot of knowledge and a lot of innovation to be gained from going ahead and saying, look what we got. It's very small, and it really will be only up there for a very short amount of time. Why not go ahead and try it as a minimum viable product? Speed is important. Getting up and out there and doing something that's useful and innovative in space, and space worthy. So but the odds are, I'm guessing, my instinct is that the size is now the biggest risk. After, I know I'm a raging optimist, so I'm assuming that all this amazing work will work, and that the software changes will be relatively straightforward. It will be work, of course, to move and test it at 70 centimeters. But looking at the way that it was originally proposed, it's really kind of interesting. Looking at what we're doing with the expanding the sensors to a beacon at microwave, these are good things that rest on previous working code bases. So I'm assuming success on that we're moving in the right direction, and that will achieve the goals. The next big worry is the physical size of this, and the FCC going, we're not going to allow that in space because we can't track it, or we won't admit that we can track it, or we don't want to encourage this size category. But I think we should go ahead and try and ring it out, because someone has to. They never came back with an answer for the original AmbaSat team. Or AmbaSat team has not admitted that their application was denied or accepted. It's stalled under negotiation. And we simply don't know. if we go ahead and do it, though, we'll tell everyone. We will disclose it.
So the biggest challenge, besides the biggest technical challenge I think that we have on this, is that the power system is totally like zero. So you know, we didn't change that for the KiCad version. It's still zero. Because we didn't fix any solar panel problems or any supercapacitors or batteries or any of that kind of stuff. So I think that's going to be, you know, once we have these in our hands and we can do some measurements and say, oh, we need 100 bursts of 125 milliamps.
Because like for any sort of beacon at microwave, I'm like, I'm not really sure that we have that power. We don't have the old power system, the originally envisioned one, to me doesn't seem to be able to produce the current that we need.
It can't produce the current. It needs to do what they proposed. So it certainly can't produce. It can't do more. So it was interesting because when I did jump on the forums over at AmbaSat, I wasn't the only one that had that question, and there was some really good research done. People were doing experiments and stuff, and they were really testing it out and saying, yeah, there's a little bit of an issue here. So.
All right. So maybe we can come up with a solution. Fortunately.
Right. That would be nice.
Yeah, it would. It'd be a big contribution, and it has to be done in order to apply for any sort of, you know, I mean, just looking at the behavior of the original one that I have in the greenhouse as a greenhouse sensor, I'm looking at the power consumption. I'm like, I don't really see how this could work. You know, that's true. So, and that, you know, so yeah, that was a when you actually have working hardware or working software, that's when you can make these conclusions and decisions. And so getting to that point as quickly as possible will reveal a whole lot more to us.
Yeah, I agree.
All right, so we're waiting for boards. We're waiting for boards, and then we'll kick it, and then that's okay. So there's no. Is there anything that I can do to help, or just hold tight?
On my side, I think it's just hold tight because the boards are coming in. I think I have all the parts that I need to build like 5, minus the gyros. You just can't get those. I bought one eval board from ST from DigiKey, and I'm going to desolder it and solder it on a board, but I'm not going to do that for I'm not going to do that for 5 boards. That's just a little crazy. But then you don't need the gyro to do what we're doing.
Right.
And so I guess we'll test the boards, and then you guys tell me who needs to get them once I have boards that are working, and then that whoever those people are, whether it's just Vidya and I, or if it's more. How do you pronounce your name? Is it Vidya? Vidya. Okay. Yes. Let me make sure I got that right. So if it's just the 2 of us, great. If it's 5, up to 5 people, great. And then I guess at that point we just need to commit to seed and see if they can actually get parts, because I don't know how they're going to get parts, but
I know, but I haven't uploaded, but he seemed the same. But I don't. Obviously, he hasn't got the GUBA yet, so he seems pretty optimistic right now. But
I'm not surprised. Whenever I deal with folks over in China, they're very optimistic about being able to do stuff. Almost all the time.
It's a project requirement.
They were not optimistic. They're like, we cannot do this. So they just told me
on my face, like, okay. All right. Well, that's interesting.
No, this is not possible. I mean, I told them the exact way I told Seed, and JLC was like, no, this is not something that we can do right now. So.
Okay. All right. Well, that's good.
Yeah, that's probably a good sign about the way things still are as of this week, and we'll just keep checking. The other neat thing about this particular board is that it allows us to experiment with a kind of a neat protocol called Sparrow, which is a covert communications example. This was presented at the most recent DEF CON. And we have the opportunity to kind of play around with it with a LoRa or LoRaWAN part, I believe. So that's another neat thing that we can do and participate in, is a proof of concept or demonstration of covert communications, leveraging the broadcast and the setup call setup or communications setup. So what I'll do is I'll put out a link to the paper and the presentation, the video presentation. So that's an additional sort of neat thing that we can do with this hardware. So it's plenty of leverage.
Is that a ham band legal function, or
it
so
is.
It's not encrypted or anything?
No, it's not encrypted. This is pretty cool. So the first 4 or 5 steps of most relatively complicated communication services are usually you as a handset putting in a bid to a tower, which is usually much more powerful transmitter sitting there in the world. And so you're putting your bid in, and then it broadcasts out a reply. You get the reply and you do something with the information, and then you transmit back to the tower. The tower then transmits back to you. That's generally this 4 or 5 step process. So the interesting thing is that in both 5G and in LoRaWAN, you as the handset get to pick the random number. Now you probably have come to the conclusion that, well, if I get to pick a random number, that means that it's not really random. You're supposed to pick a random number. You're supposed to generate a random bit of data in order to establish a call. And this also works for some very popular satellite services as well, which gives you a very large footprint for covert communications. Meaning communications outside of the service that you have either paid for or the protocol that you're using, right? So if you can specify, if you have control over the bits that you're sending that are supposed to be your little key for figuring out, filtering down the pachinko game of getting into the traffic channels, well, then what the cell tower or what the LoRaWAN or what the satellite will do for you is it will dutifully retransmit the little bit of information that you have provided the base station. And that means that your little tiny bit of data, we're talking maybe, kilohertz or less, like not a whole lot, but enough for humans especially, but that the system has rebroadcast your bit of information as if it was a random key or a random blob to a very wide area. So your intended recipient sitting out there listening and knows you've told them, okay, well, my handset ID or channel ID or whatever is this, just monitor the traffic and listen for this so-called random thing. That's really information intended for you. So this is a really kind of hot area for, because in 5G, it's not fixable without some work. So this is, and in LoRaWAN, it's not fixable without some work. And in satellite community, it's not fixable without some work, and explaining it and then making it something that, in digital communications, because we have to use these back and forth handshakes, especially for anything that's authenticated and authorized, you have to go back and forth and do something. The more that people know about these particular types of things, the better. So this hardware actually could, and I'm explaining all of this assuming that we do have that the device, that the SoC really is as flexible. It seems like it from working before with the AmbaSat and other programs. So it may actually freeze dry everything in. The random bit may actually be generated for us in this particular SoC. But if it's not, then this would be good hardware for that particular teaching moment. There's lots and lots of neat things like this in all the protocols that we use, and these lessons are good, to learn. Because then when we go to like something like M17 project, a new protocol, anything like that, then you really have to kind of look for, okay, is it vulnerable to this particular weakness? Which for M17 or anything that's narrowband, it doesn't matter as much as a very broadband commercial or public service thing, because if enough people use a covert channel, then you clog up the channel and you can actually start bordering on denial of service for quote unquote real calls. So anyway, that's one of the neat things that we can do with hardware like this.
Okay.
So interesting.
Thanks for the explanation. I had no idea. I hadn't even thought through that.
It's basically, anytime that you see random, I guess the lesson here is like anytime that you see something that's allegedly random, a dice roll in a protocol, make sure that it's not left up to the handset, you know, that it's not left up to a designer or to somebody that can program an SDR, you know, we now live in the world of SDRs. So it's assuming that something is random when it's not, we see this all the time in cryptography, and we see it here in essentially authentication authorization to establish a call. You know, who would ever think that could be a second covert channel? So what would be really cool is to use this particular board, maybe at next DEF CON to make a badge or something like that, since it's tiny, to demonstrate this, and to, you know, the covert channel could just be a marketing channel for ORI or whatever, you know. It'd be kind of fun. So yeah, plenty to learn. There's just there's stuff under every rock or every bit, every chip. Cool. All right. So I'm looking forward to it. And yeah, see you on Slack, you know?
Yep.
On Slack.
Definitely. All right. Have a good holiday.
Thank you. So far, so good.
Yeah.
Yeah. All right. Take care.